Welcome back one last time. We have three more kinematics problems and then we can all take a nap. The CN Tower. Okay, so they're talking about the CN Tower, which we met in a previous question. It's a big spire like that with a bit of a curve. Then there's an observation deck and a restaurant and a gift shop and stuff, and kind of burger shaped on the top, and like that. They give the height in weird units, 0.553 kilometers. If you multiply that by 1,000, you get that the height is 553 meters. But guess what? We're not going to need it because we aren't dropping something all the way to the ground here. We're standing at the top and we're throwing a coin off here, but we only want to know where is it after 3 seconds? 3.00 seconds. Well, the acceleration should be minus 9.81 meters per second squared. Sorry, ran over my decimal there. And they use the word dropped, which normally tells us initial velocity was 0. So, can we get a displacement from that? Definitely. And it won't even be the VF formula this time. Distance equals VIT plus 1/2 AT squared. Tells you how far you've moved from your starting position. And so in this case, our initial velocity was 0. This is going to be 0 times t, which is going to disappear. Something that physicists do sometimes, if they know that a whole term is going to vanish, just to save themselves the trouble of writing it all out, they'll put an arrow through it like that and then a 0. That means I know this whole term is going to go to 0, so I'm just going to start ignoring it right now. It's a nice clean way to do it. You'll see me do that every so often, so now you know what it is and feel free to do it as well. So displacement is 0 plus 1/2. A is minus 9.81 because gravity pulls down, and our elapsed time is 3 seconds. Don't forget to square it. 1/2, I'm putting 0.5 in the calculator, times 9.81 negative times 3 squared. We get minus 44.145 meters. And because this had 3 significant digits, I should trim my answer to 44.1. You can either say minus 44.1 meters and let the negative mean down, or if you're a fan of English, you can say 44.1 meters down or downward. It'll be 44.1 meters below its starting point. If you wanted, you could take 553 meters minus 44.1, 553 minus 44.1, and that would tell you the coin is still 508.9 meters above the ground. They didn't ask that, but it's the sort of thing that could easily come up. Good. Speedboat accelerates uniformly from rest. Okay. All right, so this is interesting. We have 3 different points here, in a way. We have a starting position. Boat goes for a while. It goes until the 4-second mark. Only then do they ask us to start measuring how far it's gone. And we're to measure between the 4-second mark and the 6-second mark. So stuff is happening from the start to 4 seconds, but we're not really going to count it. Although we may need to do some calculations there. Let's find out. This boat is not falling like a rock. It's accelerating sideways, so its acceleration is only 3 meters per second squared. They said from rest, which means our initial velocity was 0. So how fast is it going here, and how fast is it going here? We can find those. We can find those with... This is that other favorite of mine that isn't exactly on the formula sheet, except it kind of is. They give it as acceleration equals delta v over delta t. If we use this, we can find what are we doing at 4 seconds. Our velocity at 4 seconds would be our initial velocity plus our acceleration times our time, 12 meters per second. V there is 12 meters per second. And then we can do that again at 6 seconds. VI plus a t. Now we're doing 18 meters per second. Good. So we got those velocities, which is great. And they want to know how much distance did the boat cover between the 4-second point and the 6-second point. Well, we have a starting velocity of 12, an end velocity of 18. We know the acceleration all that time was 3. We should be able to find a distance doing that. And, oh, look. It comes through again. Final velocity is 18 squared. Initial velocity is 12 squared plus 2. Acceleration is 3. And the displacement is what we're trying to find. 18 squared is, I want to say 324. Yep. 324 equals 12 squared is 144 plus 2 times 3 is 6, d. If we want d alone, subtract 144 from each side, and we get 180 equals 6d. And if we want d alone, it's multiplied by 6, so divide both sides by 6, and we get our displacement is 30 meters. All these values had 2 significant digits, so giving the answer with 2 significant is perfectly fine. That would be it. And last one. A tennis player standing on the edge of a roof. So we got a building, and a person up here throws a ball upward. It slows down, stops, and then falls back down. And down here it's going to hit the ground. They tell us the initial velocity was 6. Falling objects normally get that acceleration. And what else do we know? Oh, and they say the elapsed time is 3.35 seconds. 3.35 seconds. I'll put t equals just to be very clear. Final velocity as the ball hits the ground. Well, we have one for this, and it's my favorite one that isn't on the sheet. Vf equals Vi plus At. Your final velocity is the velocity you started with plus whatever velocity you gained by accelerating. Is basically what this says. And if they want us to find final velocity, our initial was positive 6 plus our acceleration's minus 981, and our elapsed time is 3.35 seconds. Bedmass says do this first. 9.81 times 3.35. Vf equals 6 minus 32.86. That's minus 26. Minus 26.86. But our givens only had 3 significant digits, so we should trim this to 3, which would make it minus 26.9 meters per second. You can either use the negative sign to tell you that it's moving downward, or you can use the word down. It's all good.